All right, AI SL2. Today we're going to continue our work with integration, but we're going to start using a new word, which is antiderivatives. You guys have almost been finding antiderivatives so far, but we've really been doing integration with calculators and such. Today I'm going to show you a little bit of how to work backwards with integration. So here I've written two expressions. There's a 3x squared plus 6 and an x cubed plus 6x. Now you might notice that if you take the derivative of this function and then with the power rule that we learned, you bring the 3 down out in front, and then the derivative of 6x is just 6. So if I go this way, this is called differentiation. Taking the derivative. Today, which you guys have done a lot of that arrow right there in the previous unit. Today we're going to focus on being able to take this and then turn it into this. And this is called integration. Also, some notation that we're going to use today is that if, here, I'll use the blue pen. If this is f of x, and then you go this direction, like you try to find the thing that, the original function that someone took the derivative of to get that f of x, this is going to be capital F of x. So we'll make a note here that capital F of x denotes an antiderivative. It's like you're undoing the derivative to get back to the original function, but we don't call it the original function, we call it the antiderivative. Something that's going to come up, not necessarily today, but a lot next class, is that if you're taking the integral from a all the way up to x of some function with respect to t, notice they're not using x and they're using t, you need to take the antiderivative. So this capital F here is the antiderivative. And then you take the antiderivative and plug in an x, and then plug in an a and subtract the f of a from the f of x. That's how you would kind of find the area under a curve by hand. This is what your calculator has been doing for you this whole time. But yeah, we're going to start to get into some small ones using doing things by hand. First problem, find an antiderivative of y equals 4 plus 2x. So if you're going to find y equals 4 plus 2x, we're going to use capital F for the antiderivative. Now what you have to picture with this is that a derivative has already been taken. So when it comes to just a number floating on its own, that means that used to be 4x, because the derivative of 4x is just 4. So we know the first part is 4x. Now here, with this part, there's a 1 power on the x, which means that it used to be a square, and then it got dropped down to a 1. Also, you can see the square out front because it got brought out front. So this one is actually kind of straightforward. It was just 4x plus x squared. Now, whenever I think I've found the answer, I always look at this right here and I do a quick derivative in my head to see if you get the antiderivative back. Sorry, make sure you get this. So if you take the derivative of this function, I do believe that you get 4 plus 2x. So this is the antiderivative. And notice it's using the capital F, not a lowercase f. This next one says find a function y equals g of x when the gradient function is equal to 3x. That's just a fancy way of saying that, like, this is the derivative. Remember that this is just derivative notation with respect to x. So we need to work backwards to find a y equal to a function where the derivative is 3x. Now, if you look at the power on the x, it's a power of 1, which means it started out as a square. So we know that our antiderivative here is going to be something x squared. But if I just take the 2 out in front, that would be 2x would be the derivative. But we don't get a 2 out in front, we get a 3. So we have to think to ourselves, what times 2 would give us 3? It's like 1.5. So I think the antiderivative is 1.5x squared. Once again, I would take this function and take the derivative of it to make sure I get 3x, which it does, because if you take the 2 out in front and multiply it, 2 times 1.5 is 3, drop the power down 1, it works. This example, we're going to consider the function, the integral 0 all the way up to x of 3 minus t dt, and where x is only between 0 and 1.5. The first part of this is we're going to draw a diagram where this is the function, 3 minus 2t. Notice that's the inside part from up here. And shade the area represented by this whole thing. Well, this function right here is a linear function. It has a y-intercept of 3. So if I go up to, say this is 0, 3. And then it has a slope of negative 2t. So if I draw a line that goes down 2 over 1, which I'm not drawing it exactly, I'm just kind of sketching it, we can say this f of t is 3 minus 2t. Now, shade the area represented by this 0 to x. Now, we don't know where the x is. We just know it's somewhere between 0 and 1.5. So, for our diagram, we're just going to pick a spot, like right here, and say, okay, this is where t is equal to x. We know it starts at 0, so the shading is going to go from 0 all the way up to that number, and then it's going to stop. So we don't know what the x is, but we know that's what it would look like on a graph. Part B says, using antiderivatives, find an expression for this in terms of x. Well, the first thing we would have to do, well, really, the only thing we're going to have to do is do the antiderivative. Because if you plug in a 0 and an x, the zeros all go away. So really, it's just finding the antiderivative of that. So we have to take the inside, 3 minus 2t, and then try to get it back to the original, an antiderivative. So I think, once again, if you see a floating number without a t, that can just become 3t. So if this is f of x, this is capital F of x, 3t, and then minus t squared, I think is how that would work. Yeah, because if you take the derivative of negative t squared, the 2 comes out in front, the power drops down 1, you get negative 2t. So that's it in terms of t, but they said to find it in terms of x. So really, we're just going to say this, that 0 to x, I'll rewrite the original problem, 3 minus 2t dt is going to be equal to 3x minus x squared. Yeah. All right, you guys, I think that's it for now. There's definitely some good stuff in the homework problems, and then we're going to go a little bit deeper with this next class. So yeah, there's a lot more left in 13.2. All right, you guys, happy studying. Please ask me questions in class.